let's dive into the data analytics and data science. So data is kind of a massively available now, and data is a subject that all the companies, everyone wants to store, analyze, and with the advent of cloud technologies and high-end CPU and GPUs, even the end users like me and you are able to analyze a massive amount of data with a short amount of time. 10 years ago, the amount of the storage and processing unit, I think, so I wasn't at Royal Bank of Canada 10 years ago, but like based on what I heard, like 10 years ago, if someone wants to analyze a few gigabytes of data, it was only a few servers assigned that RBC purchased, and each team, each member has to gain access and basically had to like finish the analysis and then just drop that access to the server, and the other person, the next person, just work with the server, and then once it's done, you can just shut down the access and then the next person. But nowadays, you can analyze hundreds of gigabytes of data at once because of the cloud techniques and technologies and the high-end processing units. So basically, all the people, I mean, not even RBC, all the technology companies, not the finance companies, or basically can every person, every like software developer there, every person that do the coding in general is able to analyze like 100 gigabytes of data remotely on a laptop, on a server, and don't even sweat, just click and then analyzing hundreds gigabytes of data. Before that, people have to split that big data into several chunks and then analyze each chunk separately, and the lots of manual techniques that has to be involved. Nowadays, nobody deals with that. It's just as easy as just renting a server from Amazon or just from Microsoft or IBM, and or even Google, and then do your analysis and just shut down the server. You don't pay for the server anymore. You just pay by the amount of that you rented the server. You just shut it down, and the cost would be as low as like $10 or just $100. And another trend which is happening, that companies tend to store the data as much as possible. In the past, because data got massively large and they didn't have the infrastructure to store the data, just get rid of the data. So every 5 years, just like, okay, we don't want the data anymore, just get rid of the old data. So they have the capacity to store the next 5 years of data. Nowadays, they want to store as much as data as needed. Some companies, even the whole objective of that company, even some startups, the whole point is to create the data and sell the data to other companies. So data as a service, which is a topic that is kind of a trending nowadays. I think Elon Musk was saying that that company is basically is partnered with some other startups, and those startups, their job is to get the data, clean the data, and sell the data back to Tesla. So just kind of a data is kind of a gold now, and no one wants to basically remove or get rid of the data, especially when the data is proprietary data, when the data is not something that public know of. They want to keep the data, they want to use the data as much as possible, and they don't want to sell the data. They don't want other competitors aware of this data, unless like they can sell the data and just get money out of it. That's something else. But okay, so notice that my video was off. And one thing that is happening is, something that is happening is, instead of selling the data every time, like team, not only at RBC, but I'm talking about all the technology firms, all the financial firms, even when they do the analysis, they tend to sell the insights rather than the raw data, because data again is this is like a Bitcoin in the data analysis. And the more the data that you have, the better the model, better the recommendation system, better the prediction analysis that you can get. It's not like a linear relationship, but that's like a general rule that the more the data, the better the result in like data analytics. So that's why the ability to store the data, to analyze the data, especially the big data, is like very demanding and is very useful if someone wants to be successful in a career. And as you see, the application is not only to technology firms anymore. So in the past, most of these companies, most of these like e-commerce, manufacturing, banking, finance, transport, healthcare, when they have a large amount of data, they basically made partnership with a third company like Google, like Facebook, like IBM, and those companies would do the analysis for them because they didn't have the capability, they didn't have the infrastructure. Now, no one wants to do that. No one wants to basically give their own data to someone else. Even for the cloud systems, like one thing that is happening is for like big corporations like finance, which are highly regulated, trusting cloud services like AWS, the Amazon, Microsoft, Google is very difficult. What RBC does is RBC already rented some servers from Amazon. That this is different than the general Amazon servers. That is only like specifically for RBC, and whatever RBC wants to do with if RBC wants to use Amazon Cloud, they use those servers which are separated from other servers, because RBC afraid that Amazon somehow get the data and use the data without even RBC's consent, which is even illegal, but RBC company is going to afraid that. That's why having the ability for even small companies to analyze their own data without even depending on other companies is very useful. So all of these companies nowadays wants to create their own system, their own server, their own people, so they can analyze the company's data internally rather than giving external access to other companies to analyze for them. Again, in banking industry, these are some applications of data analytics and data science in general. In banking, we have fraud detection. You have a banking card, you have a credit card. If someone stole your credit card, you want to do a purchase. Bank wants to know if that purchase was kind of a fraud or legit. I lost my credit card like maybe a year ago, and that person, because I could see on my online banking that person bought a gift card from Amazon, purchased another gift card from a website that I didn't know of, wanted to buy $1,000 worth of Presto card which got declined by the bank. But the first two transactions got approved. And I called, and because my card got, after that failure of that transaction of $1,000 presto card, the RBC called me, like blocked my card, automatically blocked my card, because that transaction was identified as fraud, which is a result of like a data analytics. And I called the bank, and basically they said, okay, these two transactions they got approved, they're not going to charge me anymore, so I'm not responsible for those. But who was responsible? RBC. So RBC lost money because two transactions, which I didn't do that, someone else that thief did that, but RBC couldn't detect that as fraud. So RBC paid for those transactions. So basically, that's basically the cost of having and not having 100% accurate model, is paying those transactions. And you can think of it as a larger scale. So what if like hundreds of 10,000s of people lost their credit card, or someone can hack their credit card and gonna have like a large amount of transaction, obviously gonna lose large amount of money if the fraud detection model not very good. We have a credit risk modeling. So if someone wants to borrow some money, if someone wants to get a loan from a bank, how should the bank know that this person is gonna repay that loan timely? And of course, banks wants to make sure that the person gonna return the money even though it's not on time, because bank gonna get interest, and it's not that bad for the bank because the interest would be higher. But banks want to make sure that person is not gonna get the money and just leave the country and not coming back. So bank wants to analyze the risk of all those loans and etc. And wants basically all of these models that you can see on banking is related to data, and is related to data analytics. And the data for these kind of application is not like a small portion of data. You cannot fit that in your laptops. It's like look at in large storage data, and you have to find another like a more big data ways to analyze those type of data. In the finance, we have customer segmentation, strategic decision making, algorithmic trading, risk analytics. These are all the examples of data analytics, data science that nowadays all the financial companies are dealing with, and it's very demanding. Basically, I want to say like responsibilities or very demanding skills that financial companies are targeting. The people who are able to do customer segmentation, algorithmic trading. It's not only in technology and finance anymore. You can see in all the fields, manufacturing, transport, healthcare, e-commerce, they all in need of the data analytics skills. Self-driving cars, which basically you will see on the news every week. There's a new news on like advancement on self-driving cars, and China is leading in that technology. Car monitoring systems, enhancing the safety of passengers. In the past, because they were not aware that data analytics can solve these kind of problems, they solve it in a different way. But now they realize that data analytics, data science can solve this problem in a better way. So that's why all those problems that were classically not data analytics, they all converted to data analytics now. And like data analytics skills can basically solve all of these problems. So basically, as you can see, the cashierless like supermarkets that I think initiated by Amazon in the US. So people just pick an item from a shelf and they're gonna get charged right away without even going to the checkout or having a cashier scan it. So all of these machines or sensors, all of those images, videos are being analyzed by data analytics techniques and data science. So just keep track of time. So if it's up to me, we're gonna talk over and over again because there's a lot to talk about. Okay.